Okay, so today what we're going to do is we're going to run through the chapter on redox, and I'm just going to run through some stuff really quickly. All right, now when I teach the chapter on redox, all right, I use the word shu a lot. Okay, so if you're not here in Sec 3, you've not watched the Chem 1 videos, go and check it out. All right, so but if not, shu actually has 4 letters in there, and each letter represents a different thing. Now H represents hydrogen, O represents oxygen, E represents electrons, and S represents oxidation state. All right, so I use shu because OHO doesn't sound nice. Okay, OHOE just sounds okay. So shu. All right, so shu. Now, how do you identify if a substance is oxidized or reduced? All right, so what you want to do is you need to be able to recall that on top of O is a plus. Anything that gains oxygen is oxidized. And if you can recall that, everything else is easily filled in. Beside the plus is a minus, minus, plus, minus, plus, minus, plus, minus, reduced. So once again, if you can recall the word shu, number 1, you can recall that on top of O is a plus, and that means oxidized. Number 2, you're good. So how do we identify what is oxidized and reduced? All right, we can look at oxidation state, which is very similar to charge. We can look at hydrogen, oxygen, or electrons. Now, for me, to save time, I will always just look at oxidation state. Why? There are some reactions that involve hydrogen, that involve oxygen, but it looks like redox, but it's not. For those of you who are wondering what I'm trying to say, recently we just finished the chapter on metals. All right, so your calcium oxide and silicon dioxide, all right, in the blast furnace, I hope you recall the reaction, it forms molten slag. Now, each of them look like they gain oxygen. Some students will go, teacher, O become O3, so shouldn't calcium oxide be oxidized? Or some will say O2 becomes O3, shouldn't silicon dioxide be oxidized? The answer is this is actually a non-redox reaction. All right, okay. Now, how do we know this is non-redox? I need you to go back to oxidation state. Now, oxidation state got a few rules, right? If you have no idea how to fill that in, because some students ask, what are the rules? You need to recall that oxygen, all right, in a compound is usually -2. The only exception is when you see a peroxide, okay? In compounds, oxygen is -2. All right. In compounds, hydrogen is +1. All right. So what I will always do is when I'm given a compound, I will fill in oxygen and hydrogen first. Now, then you have in elements, or basically not in elements, for elements, right? For elements, all of them, oxidation state, always 0, always no charge. So let's use these 2 short rules first to do the calcium oxide thing. So always split the compound into elements, all right? So here we're dealing with compounds, yeah? So always split the compound into elements, step 1, and fill in oxygen first. Oxygen is -2. Now you want the overall compound to always be 0. In order for that to happen, calcium must be +2. All right, same thing, oxygen is -2. You have 2 oxygen atoms, altogether is -4. In order for the overall compound to be 0, this must be +4. Now, if I'm going too fast, let me know. Okay, in the Zoom chat box, put a question mark, you can unmute, say, you can slow down, whatever. If not, last one, I'm going to use a blue color. We're going to split the compound into elements. We're going to fill in oxygen first. -2 times 3, -6. Now, what else do we fill in? Now, we know that calcium is a group 2 metal, all right? All metals, oxidation state always remains the same. All right, okay? So in this case, it is +2. Once again, for all metals, right? When they form compounds, it will, for group 1 metals, always +1. Group 2 metals, always +2, all right? No change. Group 3, +3. All right, and you want the overall compound to be 0, and therefore this must be +4. And if you compare before and after, calcium is +2, +2, no change. Oxygen is -2. I know it looks like -2, -4, -6. Let me highlight in green, okay? -2, -4, -6. Some students will say, teacher, it's changed, right? -2 become -6. -4 become -6. No, we look at each individual oxygen atom. It remains as -2. It's -2 here, it's -2 here. Each oxygen is -2, each oxygen -2. There is no change in oxidation state. Lastly, blue color ink, you look at silicon, +4, +4. No change. And therefore, it's non-redox. So once again, although there are 4 definitions in your syllabus, I will always use oxidation state. It is the safest way to tell. All right. I know it's a bit lengthy because must fill in the charge, must calculate overall charge to be 0, then find the unknown. I know it's a bit lengthy, but once you get used to it, you get really quick. It takes like 1 minute. All right. Okay. So I rather spend 1 minute than get tricked by oxygen or hydrogen. All right. Okay. So always use oxidation state to tell if it's oxidized or reduced. And this will be the first question. All right. Now phrasing. Okay. The phrasing is actually in my notes. Depending on what you use, there's different phrasing. So for oxidation state, what I'll do is this. Okay. Let's give you a very simple redox reaction. And because once again we're just doing the chapter on metals, I will use a metal example. So displacement of metals. Yeah. Magnesium and copper sulfate. All right, magnesium is more reactive than copper. You're going to get magnesium sulfate and copper metal. Now, how do I know this is redox? I fill in oxidation states first. Okay, all elements by themselves, no charge, 0. So this is 0, 0. Basically, anything that's by itself, uncombined is always 0. Okay, and then sulfate is 2 minus, 2 minus. This is 2 plus, 2 plus. Okay, and so we know that the oxidation state goes from 0 to +2. It goes from +2 to 0. Now, once you're clear on that, you can structure your answer. Okay, now some schools use slightly different versions. Here is mine. Okay, so first of all, I always start with what is oxidized or what is reduced. So magnesium is oxidized. And how do we know this? The oxidation state of magnesium increases from, now always give me a number in the reactant, 0 in Mg to a number in the product, +2 in MgSO4. That's it. We try again. What is reduced? Now, copper to sulfate is reduced. All right. Now, some schools, the teacher will say copper in copper to sulfate. That's fine as well. All right. Okay. So either copper to sulfate is reduced or copper in copper to sulfate is reduced. Both are okay. All right. The oxidation state of copper, always the name of the element, decreases from +2 in CuSO4 to 0 in Cu. Now, for those of you who just joined, all I'm doing is I'm doing a quick recap of what redox is about. Okay, so you didn't miss much. All right, I basically started, sorry, screw up a little bit. I basically started with SHU, number 1. So the 4 definitions of redox: oxidation state, hydrogen, oxygen, electrons. I talked about how to fill in oxidation states, because some students cannot do that. Always fill in your compounds first. All right, always start with oxygen and hydrogen first in compounds. Elements, always 0. All right, okay? And then I used calcium oxide with silicon dioxide as an example on why I will always use oxidation state. I will never ever explain in terms of hydrogen or oxygen. That's just not what I know. I will always use oxidation state. All right, okay? And then I give you an example of how to structure your answer here using oxidation state. All right, let me highlight the important parts. Tell me what is oxidized. Number 1, why? Oxidation state of name of element increases from number in reactant to number in product. Once again, tell me what is reduced, copper or copper sulfate. Either copper in copper sulfate or copper sulfate is reduced. Why? Oxidation state of name of element decreases from number in reactant to number in product. Okay, now I'm going to pause for a short while and check. And are we doing okay? If you're okay, can I get a thumbs up? Okay, so most are okay. For those of you who have no thumbs up, I'm just wondering whether or not you're not okay. Kai Ken, Kai Jun, Trisha, okay? Am I going too fast? Yes. Thank you. So question. So in redox, hold on, let me read the question again. The question is this: in a redox reaction, does this mean the oxidation state of oxygen must change? Yes. If oxygen is used as a reactant or product, wait. No. We don't look at oxygen. Basically, for redox, as long as there's a change in oxidation state for any element, is redox. So you see here, this one, oxygen never changed, ma. The sulfate SO4 2 minus is a reactant. Sulfate SO4 2 minus is a product. It didn't change. So it's not oxygen. As long as there is a change in oxidation state. Yeah, it's redox. Once again, as long as there's a change in oxidation state, it's redox. Okay, I hope that answers the question. Next question, for order of identifying charges. Okay, Ken. So how do you know what to fill in first? Good question. Some students will ask, teacher, for example, okay, let's do some examples. These are quite simple. I think they're quite textbook, like potassium manganate 7 or K2Cr2O7. All right, what do we fill in first? All right, now for me, I will always split the compound into elements. For me, I will always fill in hydrogen and oxygen first. So -8. Then I will look for metals in group 1 and group 2. Because they will never change. Group 1 always +1, group 2 always +2, +1. And then, of course, I mean, most of the time they'll tell you what they want to find. So they'll say find the oxidation state of manganese. So in this case, I know that everything must add up to 0, right? So how to add up to 0? +7. Now I'm going to say this. Some students, right? Okay, I've taught this for, I don't know, 10 years. I won't say 20 years, 10 over years now. Some students just cannot figure out what Mn is. They're like, teacher, I don't know how to find the blank. Let me show you what I mean. Some students will just struggle with this number here. They will look at it and they go, oh, I know, -7, that kind of thing. So if you are that kind of student, all right, what I try and do is I try and use a bit of algebra. Let me help you. So if you don't know what the middle number is, you can let this be x. Okay, then I know that +1 plus x -8 must be 0. So the overall charge must always add up to 0. Oh, +8 to 0. Then you use algebra. Then, I mean, if algebra still cannot work, then I don't know, 7. But oxidation states must have a plus or minus sign, put the plus sign there. Okay, I hope that helps, number one. Another one here, I'm going to split into elements. Oxygen is -2. 7 oxygen atoms is -14. Potassium is +1, 2 of them is +2. I want the overall charge to be 0. Once again, if you cannot do, let this be y. So +2 plus y minus 14 equal to 0. Y is +12. So this number here is +12. But hey, I want the oxidation state of chromium, each chromium atom, not 2. And therefore, oxidation state of chromium is +6. You just divide that by 2. Same thing, I'm going to pause for a little while. I'm going to take questions. Once again, the benefit of this workshop is that everybody is anonymous. No one's on camera, right? So I feel like I'm in the zoo actually, because everybody's staring at me. Some of you have no idea how you look like. But more importantly, all right, anonymous means you can ask me whatever question you want in the Zoom chat box. Let me know if you need anything, all right? Okay, no questions. No questions. What I'm going to do here is this. I'm going to look back. Okay, so I'm almost done here. Now, the difficult one is electrons. And I'm going to say this. It is possible that I explain electrons now and you still don't understand. Okay? Okay, I got another question. I'll answer that later. Okay. What are common non-redox? Okay, so electrons, okay, I'm going to say this, electrons is difficult, okay? However, O-level examiner also smart. They know it's difficult, ma. So in the recent 2 or 3 years, they always come out electrons. In terms of electrons, explain why redox. Some students like, wow, I only study oxidation state. All right, so how do we do electrons? Okay, let me keep it really simple. I'm going to use the exact same reaction, the magnesium one. Some students are like, why do I use the same thing? Because it's easier with a familiar reaction. Okay, now we know that element uncombined always 0. Sulfate forever and ever 2 minus, -2, 2 minus, -2. Magnesium, group 2 metal +2, copper 2 +2. All right, now I'm doing electrons. Some students will ask, teacher, what you feeling oxidation state for what? Now, I encourage you, unfortunately, I know this sounds a bit wrong, but I encourage you to play cheat. All right, when asked to explain electrons, explain redox in terms of electrons. Number one, fill in oxidation state first. Because it's really very hard to see electrons. All right, but it's easy to see oxidation state. It's easy to see charge. So I will fill the oxidation state first. Then I will play cheat. I'll write SHOE, S-H-O-E. Plus, minus, plus, minus, minus, plus, minus, plus, oxidized, reduced. Okay. Step 2, what I'll do here is this. I know magnesium from 0 to +2. Oh, I know that the oxidation state increase. And if oxidation state increase, it will lose electrons. I don't really visualize what's happening, but I know because oxidation state increase, it must have lost electrons. So what is step 2? All right. Step 2, use SHOE and oxidation state to determine if electrons are gained or lost. That's it. So I just play cheat. And so how do I structure my answer now? Oh, I know magnesium is oxidized. It loses 2 electrons to form Mg2 plus in magnesium. Nothing. That's it. As long as the examiner sees it's oxidized, okay, I know what you're doing. And how come it's oxidized? Because it loses 2 electrons. Done. All right. Am I really able to visualize what's happening? Well, I mean, I can, but if you cannot, never mind. Use the SHOE to kind of play cheat. Once again, let me repeat what I just did. Okay, so I'm going to use yellow color highlighter. This is +2. This is 0. So from +2 to 0, what happens is that the oxidation state decreases. All right, so if oxidation state decrease, once again, green color highlighter, oxidation state decrease means that it must have gained electrons. What gain electrons? Never mind, I'm not too sure. You just write something gain electrons, okay? So in this case, copper in copper 2 sulfate gains 2 electrons to form, oh wait, oops. Copper in copper 2 sulfate is reduced, sorry about that. It gains 2 electrons to form copper metal. That's it. That's how we answer redox in terms of electrons. All right. Without writing oxidation state, it's really quite hard. I can't do it. I mean, it will take some effort. It's like mental sums. All right. Okay. So I rather write oxidation state. Any questions? Opening up to the floor again. Come on, ask. I'm going to say this again. I know a lot of you have heard me say this before. My biggest fear, of course, is I don't know whether or not you understand because I cannot see your face. You know, some people, if you don't understand, they look really lost. You can tell from the face, right? But with the blank screens, I don't know. So you got to give me feedback. If I'm going too fast, too slow, if you're zoning in and out and you're lost, let me know. All right, okay? But if not, I don't see any questions in my Zoom chat box. I'm going to move on, yeah? All right, okay? Yeah. Now, so next one, we're almost done, all right? The color one, I'm going to pause for a little while, okay? I will answer that question in a while. Let me talk about the common non-redox ones first. So what are some common non-redox reactions? There are 4. Now, one of them is neutralization. So someone asked, is neutralization the only one? Now, there are actually 4, but I don't encourage you to memorize. How come? Because, let me type it out first, and then let me tell you one. So the 4 non-redox reaction. Number 1, neutralization. Number 2, thermal decomposition of metal carbonates. Number 3, ionic precipitation. And number 4, acid and carbonate reaction. Now, so these are 4 non-redox reactions. Now, why is it I don't encourage you to memorize? You see, some students, they are very strong at memorizing, but they just cannot identify a reaction. So, for example, you go into your exam, right? You memorize there are four of them. You memorize, for example, you memorize ionic precipitation. Now, if you're not that good with chemistry, right, you could be staring at an ionic equation reaction, right? But you also don't know it's ionic precipitation. All right. I don't know whether or not you understand what I'm trying to say. So, for those of you who are not too good with chemistry, I could perhaps write an equation like this: iron chloride and silver nitrate to form silver chloride and iron nitrate. This could be one of your options, A, B, C, D, all right? And they ask you which is non-redox. You could be staring that and you don't know. Why? Because you don't know that this one here is a precipitate and this is actually precipitation and therefore non-redox. So if I were you, rather than memorize, every time a question asks which is redox, which is non-redox, I will fill in the oxidation state and very quickly check which one got no change, non-redox. All right? So non-redox reactions are basically reactions that do not involve change of oxidation state. How to know if solid? Good question. So I know it's a solid from the solubility table. Remember, there are no dumb questions, there are only unanswered ones, okay? All my graduates will tell you the same thing. I repeat myself a lot of times. I don't believe in dumb questions. Don't know, just ask, all right? Okay? Anyone else with questions? So once again, will I memorize it? I mean, yes, I memorize it because I've been teaching this for the last 10 years and I repeat it every single year, 3 times, 4 times a year. But if I were you, all right, and you're not very confident whether or not you can spot the reaction, every time they ask you MCQ which is non-redox, go and calculate oxidation state. As long as there is no change, non-redox. And there is a cheat code to this as well. All right, what's the cheat code? All reactions that involve elements are redox. Okay, every time you see an element form as a reactant, hold on, I see a blinking box, give me a while. Every time you see an element form as a reactant or a product, every time you see an element in the balance equation, confirm redox on. Don't have to check, don't have to count, because the element must either gain electrons or lose electrons. Okay, if an element is a reactant, it will either gain electrons or lose electrons to react. If an element is formed, it's because it gained electrons or lose electrons during the reaction. Any reaction that involves elements confirm redox. Don't have to go and calculate. Cancel it out. Hey, the one who asked me for decomposition of metal carbonates, I'm going to make a bit. I'm going to. Oh wait, I just did this lah. Calcium carbonate blast furnace. You heat up, form calcium oxide and carbon dioxide. This is thermal decomposition of metal carbonates. Okay? Hello. Never mind. Ask. Element as in charge with zero and solid. It doesn't have to be solid. Element can be gas as well, as long as. So what is an element? Let me give you an example of a few reactions. Okay. The most common reaction, of course, that I'll cover in a couple of weeks' time is Haber process, right? So nitrogen gas reacting with hydrogen gas, okay, to form ammonia gas. Notice how this reaction here involves elements. Any reaction that involves an element is redox. I don't even need to calculate. This one confirm redox. All right, now I'm going to pause for 1 minute. For those of you who just joined, I know it can be a bit difficult to figure out what I'm doing. All I'm doing right now is I'm answering these 5 questions. All right, okay? I'm now talking about what are some common non-redox reactions. Okay, so I don't advise you memorizing it, but if you want to, you can copy this list down here. These are your 4 common non-redox reactions. I just give an example of ionic precipitation here. Oops, shit. Sorry, here. All right. I gave an example of thermal decomposition here. All right. Neutralization is just acid and alkali, so you can write that on your own. Acid and carbonate, same thing we did last year, right? Okay. Oi, don't. Okay, no stupid question. Okay. Now, if you are trying to do a displacement question, this boy, and you add less reactive metal to magnesium sulfate, then there's no displacement. Then obviously, if there's no displacement, then it's non-redox lah. Oi, don't. Okay, and yeah, if there's no reaction, it's non-redox. Okay, don't. Yeah, so that's it. But it's fine. Keep asking. Like I say, anonymous lah. So the only person who will laugh at you is me. No, I'm kidding. I'm kidding. I'm kidding. All right, now anyone else? Any other questions? I want to move into the question paper. Got quite a lot of questions. I think I realized a bit too many. So to answer your, let me rewind a little bit. Someone asked, I said this, okay? The cheat code is this. When you are given MCQ questions and you ask which is non-redox, as long as it involves an element, it is confirmed redox. The element can be any state, can be solid, liquid, gas, doesn't matter. As long as it got element, right? That one confirm redox. Okay, because elements must gain electrons, lose electrons. Elements oxidation state will increase or decrease. Right? So as long as it involves an element, it is redox. How do you know if it's non-redox? As long as there is no change in oxidation state, non-redox. You will never see me use oxygen or hydrogen. What's the difference between oxidation state and electron gain or loss? Still confused. Okay, let me figure out what you're confused by. So oxidation state is the charge. All right. Another way of saying oxidation state is charge. Electrons must be gained or lost before particles can gain charge or lose charge. So they are related, but we don't explain them the same way. So back to this, all right, back to this example here. You're asked to explain in terms of oxidation state, which is very similar to charge. We just look at the plus minus. So I'm going to highlight in green. We look at the charge and we just talk about it. But if you're going to ask me, teacher, why is there a change in oxidation state? Why is it increases, it decreases? It's because electrons are exchanged. At a fundamental level, magnesium atom here is giving away 2 electrons to form magnesium ions. And when it gives away 2 electrons, the oxidation state will go from 0 to +2. So it's related. All right, you cannot say, I mean, yes, we answer the question, we compartmentalize. If the question wants oxidation state, we say oxidation state. When the answer wants electrons, we give the electrons. All right, but what brings about a change in oxidation state is the gain or loss of electrons. All right, okay, so I hope that answers your question. Okay, are we still confused? Notice I'm not calling names because I know you want to stay anonymous. So let me know if you're still confused. Okay, great. Sigh of relief. Okay, now, so let's, another question. Oh, no problem, no problem. Let's move on to the questions. All right, okay. So what I'm going to do here is this. Let me think. I think got a lot of questions. Oh, 5 questions. 5, 4, 3, 2, 1. Okay, I tell you what, I'll run through the structured questions first. The MCQ question if you're all right. Let me run through MCQ. Let me show you how to approach the questions because we are running out of time. Okay, we have half an hour left. Now, so here you ask which series of changes involves both oxidation and reduction. So you want the oxidation state to increase or decrease. Now, some students will go, can I look at oxygen and hydrogen? Yeah, you can, but I don't like to. It's just not me. Okay, but yeah, okay. So anyway, anything that's uncombined by itself or 0, 0, 0, or no charge. If this is -2, this is +2. All right, this is -2 times 2 minus 4, this is +4. Notice how the carbon goes from 0 to +2 to +4. Oxidation state keeps increasing. Only got oxidation, got no reduction. A wrong. Oxidation means oxidation state increase. Reduction means oxidation state decrease. Now you're wondering, teacher, why don't you use oxygen? Faster, ma? You can, but I tend to use oxidation state because the more I do, the faster I get. So in my head, I can actually already see the next answer, but I'll work it out with you. All right, okay? So the next one, lead oxide. Let me get rid of that first. -4 plus 4, minus 2, plus 2. All elements by themselves uncombined 0. Oxidation state goes from plus 4 to plus 2 to 0. It keeps dropping. Is it oxidized? No, it's purely reduction. Also wrong. So there's some airplanes behind, so just bear me for a while, okay? Next one, let me increase the screen. Okay, 0. Okay, now if you've always struggled with filling oxidation states, this is for you. Split plus 3 minus 3. Split minus 2 plus 2. I think this one got chance. Why? 0 to minus 3. Oxidation state decrease. Plus 3, minus 3 to plus 2. Oxidation state decrease. Reduced, oxidized. C. That's it, done. Okay? So that is your MCQ. Do I need to work through the last one? I'm going to say this. If you're very confident with your redox oxidation state calculation, you don't have to. If you're not very sure, you're scared you make error, you can go and do it. But explain the difference between redox, non-redox. So, okay. Redox reactions in general are reactions that involve a change in oxidation state. Non-redox reactions let me try and make it easy for you. Are reactions where oxidation state remains the same. I think that's a lot clearer, rather than the do not part. All right. So one got changed in oxidation state, one remains the same. Okay, I hope that answers the question. Yeah. All right. Okay. So, but here it's not redox. Here it's oxidized and reduced. So I want something oxidation state go up and go down, and that answer is C. Okay. Anyone any questions? Yes. No. If not, moving on. Here, another fairly simple MCQ. You're asked to fill in oxidation state of sulfur. So here we're just giving you the skill you're being tested on is calculating oxidation states. If you can calculate oxidation states, you're good. If you cannot, gone. I was going to say you're shit, but yeah, wrong. Yeah, gone. All right, okay, so 0, minus 4 plus 4, minus 6 plus 6. So let's look first. 0, 0, 0, wrong. Plus 4. Let's do the plus 4. What's my plus 4? Plus 4. Answer A. This one is what? This is 1, 2. This is plus. This is 2. That is 4. Oh, wait. I have another one there. Crap. Plus 4. Okay? So B also wrong. And then plus 6. Plus 6. Plus 6, plus 10. So no choice, I have to do the last one, all right, okay? Actually, it'd be faster if I just did it from the start. H2SO4, split the substance into elements. Done. Fill in oxygen and hydrogen first. It doesn't matter if it's H or O or H. Fill those in first. Minus 2 times 4, minus 8. Hydrogen is plus 1, okay? Plus 1 times 2, plus 2. Overall 0. What is left? Change color, plus 6, plus 6. Okay, that's it. All right, same thing. I'm going to give you a short breather. All right, I'm going to take questions. If you have any questions, please put it in the Zoom chat box. Some of you, I know you might be copying and then you have no time to type your questions in. So I'm going to give you 30 seconds. If you have questions, please let me know in the Zoom chat box. Okay, if not, I think we're all good, yeah? All right. I hope I didn't leave anybody out. Okay, hold on. Okay, everybody. Now, last one. In which pair is the underlying element oxidation state? Same oxidation state. Sorry, in both compounds. So I basically want, I didn't underline. Okay, let me underline for you, okay? It's quite obvious now. Chlorine, chlorine, sulfur, sulfur, iron, iron, manganese, manganese. All right? Okay, I tell you what, I give you 2 minutes to go and try. Okay, go and try in which pair is the underlying element in the same oxidation state. Try. Then let me know your answer by typing the letter in the Zoom chat box. I know if you're online, usually on MCQ, we don't type answer. But for now, I want to see an answer for question 3. Is it A, B, C, or D? Go work it out. All right? Okay, I have 2 answers so far, and both are okay. Both are correct. Okay, I'm going to wait for a few more to. Okay, so some coming in are not quite right, yeah, right, okay. And because it's now 50-50, like 50% correct, 50% not correct, I'm going to run through, okay? Some of you, I think, are still doing, I hope you're doing, okay? You're not just there, sitting there, eating popcorn and shaking your leg. Okay, if you don't know, put question mark, very good. Now, why got change answer one, friend? But change answer still not correct. Okay, never mind, let's run through, okay? I run through from the bottom. So manganese oxide, MnO2, and then MnCl2. So if you split, right, always fill in oxygen first, -4 +4. Now, in this case, all right, in this case, because they ask you to find Mn, all right, there is no oxygen, there is no hydrogen. So what do? You fill in the other element first. If you want to find manganese, then you got to fill in whatever. So chlorine is in group 7. For those of you who are not sure, I'm sorry, if you have no periodic table at home and you have no idea what group chlorine is in group 7. Group 7 means -1 times 2, -2. This means manganese was +2. Are they the same? They're not the same. All right, so D wrong. Can. All right. C, Fe2O3, FeSO4. Okay. You want to? I'm going to split it this way. Okay, this one element -6. Okay, this must be +6 divided by 2. I get +3. Okay. A little bit. For those of you who feel like you're okay, you can either move on to the structure or you can, watch the replay if you have other homework to do. All right, okay. So this is +3. All right. Here I'm going to fill in oxygen first. This is -8. Okay. Now I want to figure out what sulfur is. Sorry, what iron is. Now this is a bit difficult. What I'll do instead is this. I will do sulfate. SO4 2 minus -2 +2. All right. So this one here, is it the same? No, not the same. All right, okay. And then we have H2S, so it's H2S, SO2, split. Fill in hydrogen first, +1 times 2, +2. This is -2. This is -4, this is +4. All right, okay. So notice once again, the sulfur different, so also wrong. And therefore, the correct answer is A. Only the first 3 who filled in got correct, okay. Now, correct, so A. Why? Copper chloride. Sodium chloride. Copper is +2. This is -2 divided by 2, I get -1. +1 -1. Same. And therefore answer is 8. Okay? So take some time to process that. Let me know if you need me to run through anything again. If you have any questions, yeah, just keep it coming. How you know sulfate -2? Oh, okay. Because Okay, you must memorize certain anions. Sulfate, you know, right? SO4 2 minus. So the charge is minus 2 lor. Okay. Nitrate, if I see nitrate, right, I will not split into nitrogen and oxygen. Nitrate is just no 3 minus. Of course, unless they ask me to find the oxidation state of nitrogen. If not, I will consider it as one whole, minus 1. Or carbonate, 2 minus, minus 2. Okay. So that's MCQ, and that's that. So we're going to try some questions. Okay, can I? Let's try question number 1 and 2. Okay. Yeah, I think rather than I run through everything, I'll give you some time to try. Yeah, I'll give you 5 minutes. 5 minutes. Okay, 2, 3, 4, 5. 5 minutes. I tell you what, we just try the redox part, can part C. Yeah, just do part C. If you have no idea how to do part C, let me know. Okay, so some are a bit stuck, right? Because I see some question marks in the Zoom chat box. So calculate oxidation of chlorine in chlorine dioxide. So what is chlorine dioxide here? All right, so this one a bit strange, all right, okay. Part 1, okay, ClO2, split into elements. Now, oxygen is always minus 2, all right, okay. Minus 2, wait, let me think, yeah, minus 2 times 4 is, minus 2 times 2 is minus 4, all right, so this one must be plus 4. That's it. Okay, so it's a bit interesting, but bear in mind the oxidation state of oxygen in compounds is always minus 2. If you didn't catch that, I'm going to write it down here, and I'm also going to give you the exception. Okay, so the oxidation state of oxygen in a compound is usually minus 2. Exception when, except for peroxides. In peroxides, oxidation state of oxygen is minus 1. So oxygen, for oxygen, depending on what the compound is, it's either minus 2 most of the time or minus 1. All right, okay? Yeah. We ignore the 4. So bear in mind, when you do redox, right, we do not look at the number in front. The number in front, right, is just used to balance the equation. Don't look at it. It's for mole calculation only. No, that later on when we do enthalpy change, we also need a number in front. But for now, we are calculating the charge of each atom. So we don't look at the number in front. Even if you wanted to consider the number in front, you have four ClO2s. In other words, ClO2, 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 ClO2. You have four of them. And so, do you need to consider all four? No, we just look at one single ClO2. All right, okay, so ignore the coefficient. All right, okay. And here you're asked to explain why it's disproportionation. So let's look at chlorine. They will tell you chlorine, right? So here, okay, fill in a -2 plus 1. Chlorine here in red color must be +1. Okay, I'm going to do the same thing. Split into elements. Ignore the 3 in front of the H. This is -6. All right, this is +1. And in order for the whole thing to be 0, this is +5. Now, if you're able to do this, +1, +5, +4, you are okay. All right, okay? That's really almost all there is to redox for now. All right, so why is it disproportionation? The oxidation state of chlorine increases from +4 in ClO2 to +5 in HClO3. It also decreases from +4 in ClO2 to +1 in HClO. That's it. And therefore, it is what you call disproportionation, right? If you've never heard it before, disproportionation is when oxidation state of the same element, in this case chlorine, increases and decreases. Here it increases and decreases, therefore disproportionation. That. Any questions? All right, if you have no questions, I'm going to run through the next one. If you need a bit more time to copy, let me know. All right. If you have a question, I'm going to give you 30 seconds to put it in the Zoom chat box. Anyone, any questions? Going once, twice. Okay, now let's move on. All right, next one here is this. You're given chlorine gas and sodium hydroxide react. Okay, so here we have cold dilute sodium hydroxide. Here we have hot concentrated sodium hydroxide. So chlorine in blue and sodium hydroxide react differently. It's the same reactants, but one cold, one hot, one dilute, one concentrated. Okay, with hot concentrated sodium hydroxide, chlorine is oxidized only. So let's look at the hot one. Anything by itself, 0. Sodium chloride, +1, -1. This one, -6, +1. What is the chlorine? If you count carefully, it is +5. Is it oxidized only? No. Oxidation state increases, but also decreases. So it's also reduced. And that will give you 2 marks. All right. Chlorine is oxidized to a larger extent. So, okay, maybe I should type it up. So, do you agree? No, disagree. Disagree. The oxidation state of chlorine also decreases from 0 in Cl2 to -1 in NaCl. And chlorine is reduced. Wait, let me think if I want to write in the oxidized one. Explain whether you agree. Okay, I tell you what. Chlorine is reduced. I'm going to write both. increases from 0 in Cl2 to plus 5. All right, okay, so it's basically both oxidized and reduced. All right, okay, so do you agree? Now, why did I go and write a little bit more? Because agree, disagree questions, you won't get any marks. You can get this correct, but 50-50 questions won't get marks. Because the examiner will not know whether or not you chose it correctly or you got lucky. So 50-50 options usually don't carry any marks. So because it's 2 marks, I'll tell them what happens to chlorine. It is reduced and it's oxidized, and therefore I disagree. All right, okay? So if you're wondering why I wrote, it's not because I'm kiasu, but because I considered the mark allocation, and therefore I went with that. Okay? I know some of you will need some time to copy this down. If you're done copying, if you have a question, please open up your Zoom chat box and let me know. If not, if not, let's do part B, okay? Chlorine oxidized to a larger extent. So what you want to see here is this. This one 0, okay? Plus 1, minus 1, okay, the same. Here, minus 2, plus 1. In order for the whole thing to be 0, chlorine must be what? Ask yourself. Plus 1. And therefore, is it oxidized to a larger extent with hot? No, yes. Because from 0 to plus 5, sorry, 0 to plus 5 compared to 0 to plus 1. So it's oxidized to a larger extent. Okay, so larger increase in oxidation state, hence oxidized to larger extent. How do you put that into words? Let me type it out here so we can see. All right, okay, part B. Oxidation state of chlorine increases from 0 in Cl2 to plus 1 in NaClO when whole dilute sodium hydroxide is used. Oxidation state of chlorine increases from 0 in Cl2 to plus 5. With hot concentrated sodium hydroxide. As oxidation state increase is larger for hot concentrated sodium hydroxide, chlorine is oxidized to a larger extent. Agree. All right, okay. I know it's very lengthy. Yeah, but I would go with that. Anyone, any questions? Yes, no. I don't know if you're copying. I don't know if you're done. So I'm going to say this, okay? Once you're done, can I get you to do a thumbs up? And then I'm basically looking at your names. Once I see a thumbs up, I know you're done. I can move on. For the rest of the questions, I'm not going to run through everything like that. I'm going to tell you how to do the questions instead. I don't want to end too late as well, okay? So it's 8:30 already. En Kai, Jing Han, Jonas, Jermaine, Shivani, let me know if you're done, okay? Once again, once you're done, thumbs up. I want to know that you're good. Thanks, Daiho. Okay, I got questions. Can I say some extent? All of the blue is from part B. Can I say some extent? Some extent. Okay, thanks. I think most of you are done, which is great. I don't think by some extent. Oh, right. Okay. I'm literally just copying this, but chlorine is oxidized to a larger extent. How come? Oxygen state increase. Oops, sorry. Oxygen state increase is larger. All right. I know it's a bit hard to see what am I doing. Let me try and shift it. Yeah, I'm basically answering using the question to answer it back. Yeah. Okay. So I hope that helps. Now, so after a while, you realize, right, that most of the redox questions, right, all similar one, okay? So let me just very quickly run through. I'm not going to, how to do, okay? We're not going to do anymore. All right, so here, you're given a barium salt, never seen before, all right? Iron in the highest oxidation state. They ask you to calculate the oxidation state of iron. Can calculate, yeah, split into elements, calculate. And then, would a reaction take place when you place it in potassium iodide? Okay, can. So now, this part here, you need to know what's happening. All right, okay? What is happening right now is this. You need to know when you see potassium iodide, when you see potassium manganate 7, they're basically tests for oxidizing reducing agents. All right, okay? So here, test for oxidizing agent. All right? If a substance, okay, wait, at Ki, AQ. If a substance is an oxidizing agent, there will be a color change from colorless to brown. So what I'm trying to say here is this. If a substance is an oxidizing agent, then your potassium iodide, the iodide ions will get oxidized to iodine. Now, for those of you who are not too sure what's happening, potassium iodide is Ki, aqueous. It contains both the potassium ion and of course the iodide ion. What is responsible for the color change? Iodide. If you have something that is an oxidizing agent, your iodide ions will get oxidized to form iodine. And aqueous iodine is brown. Okay. So once again, if an oxidizing agent is present, it will oxidize your iodide ions. This is colorless to brown. All right, okay. So yeah, and here let's roll back on the question. Okay, so BaFeO4 minus 8 plus 2. Right, okay. Yeah. So for some strange reason, this ion here is plus 6. Okay, once again, it must always add up to 0. Okay, plus 6. We never see before. Usually we deal with ion 2, ion 3. Now, because it is plus 6, all right, what can happen is that the ion plus 6 can gain electrons to form plus 3 or plus 2. All right, so will a reaction take place? I would say, yeah, it will. All right, okay. Now, another thing, those of you not familiar is this, all right? Potassium iodide is actually a reducing agent. Once again, it is used to test for an oxidizing agent. Itself, it is a reducing agent. All right, okay? So how come it's a reducing agent? Because the iodide ions can give away electrons. Imagine I'm iodide and I give you electrons. You're going to become more and more negative. You're going to get reduced. And that makes me the reducing agent. All right, okay? So iron 6 can get reduced to iron 3, iron 2. Will the reaction take place? Yeah, it will. All right, so potassium iodide is a reducing agent. It will reduce the iron from plus 6 to plus 3 or plus 6 to plus 2. Hence, a reaction will take place. Okay, Kenna? So here, the key idea here is this. To test for oxidizing agent, you want to add Ki. If oxidizing agent is present, color change, colorless to brown. First thing you must know. Second thing you must know here is this. That makes Ki is a reducing agent. We use reducing agents to test for the presence of oxidizing agents. All right, okay, so I hope you understand this. If you have a question, please put it in the Zoom chat box. Anyone any questions? Okay, if not here, this is a very simple, basic, straightforward question. Here we have displacement. Explain why redox. Please use oxidation state. How to do oxidation state? Fill in first lah. 1, 2, -2 plus 2, -2 plus 2. Then go and talk about oxidation state, increase, decrease, oxidize, reduce. All right, okay? Define oxidizing agent. Okay, so here, I pause for a while. Let me roll back a while. Now here, I said that Ki is a reducing agent. Why? Because it goes around giving away electrons. It is an electron donor. Where do the electrons come from? It comes from the iodide. Iodide got electrons. It will go around giving away electrons so that they become iodine. All right, so if reducing agents are electron donors, oxidizing agents are electron acceptors. Oxidizing agents will go around oxidizing other people. Okay, for me to oxidize another substance means I will take electrons away. Then the other substance will become more and more positive, it gets oxidized. So once again, oxidizing agents are electron acceptors. Okay? So which one accepts electrons? Of course, in this reaction, it's zinc. Okay? Explain the role, it will accept electrons from copper ions. All right? Yeah. And then name one ion that can oxidize copper. What can copper react with? Silver. Okay, Ag+. You must remember, magnesium ion, copper cannot. So copper, for those of you wondering, and silver ions, copper more reactive, right? Will form copper ions and silver metal. Put a 2 there, put a 2 there to balance it. All right? So notice how copper is oxidized. Okay? And then suggest a stronger reducing agent. So, so we know that zinc is, maybe, no, I'm wrong. I'm wrong. Sorry. Hold on. I made a mistake. Oxidizing agent is copper sulfate. It will accept electrons from zinc. Sorry about that. So electron acceptors, right? The copper ion will take electrons from zinc. So zinc gets oxidized. So who oxidizes zinc? Copper sulfate. So suggest if copper sulfate is the oxidizing agent, zinc must be the reducing agent. Name a more reactive metal. Any more reactive metal? Magnesium, sodium, calcium, whatever. All right, okay. Anyone, any questions? So I'm going to say again, okay, I recognize that the reducing agent part, oxidizing agent part can be a bit confusing. I'm going to say this again. If I'm a reducing agent, I will go around reducing other substances. How do I do that? I give away electrons. If I give substance A 1 electron, A becomes negative, A is reduced. I give B electrons, B becomes negative, B becomes reduced. Everybody is reduced because of me. I'm a reducing agent, I'm an electron donor. If everybody gets oxidized, I'll be an oxidizing agent. How do I achieve that? I take away electrons, they become more and more positive. So electron acceptors are oxidizing agents. Right? Okay? So watch out for them. If not, it's 8:40. I have one last question. This one I think is quite simple. If you want to, you can try it. Take a picture and WhatsApp me. All right. I just want to, yeah, I'm going to end in 1 or 2 minutes. I just want to check if anyone else has any other questions for me. Open up. I know to compress everything in 1 hour is a lot. So if you have questions, please feel free to put it in the Zoom chat box. Anyone at all? Okay. Now, if you have no questions, I'm going to say this again. If you are hardworking, you want to do everything you can, then take a picture of it. Actually, if you can do a cam scan of it, it'll be easier for me. So you do a cam scan, PDF it to me. I can mark your PDF, send it back to you. If you send me 5 photos, everybody send me 5 photos, I'm going to be flooded with crap load of photos on my phone. All right, okay. So if you want to send me work, please send me a PDF. I can annotate on it. I can send it back to you. All right. Anyone else? Any other questions? Okay, if you have no other questions, I'm going to end here. All right, that's that. For those of you who have class with me on Thursday and Saturday, I'm going to say this. I know Saturday, a lot of families may be doing like reunion. If you cannot make it on Saturday, please let me know in advance. I can fit you in my Wednesday, tomorrow, or my Thursday class. All right, okay? If not, that's basically it for tonight. And then I will see you when I see you. Okay? Adios. Bye-bye.
Bye, teacher.
Bye-bye. Bye-bye. Bye, Jermaine. Bye, Jing Han. Bye, Evangeline. Bye bye. Bye, Katrin. Look at 4E. Okay, can. Shivani, if you have a question, you can hang around. Daihong, let me answer you in a while. Shivani, Daihong, name an ion that can oxidize copper. So, which ion can accept electrons from copper? Basically, which ion can react with copper? And you need to understand this, that copper is an unreactive metal. Only metals less reactive than copper can react. Here, once again, for part E, right? Which ion can oxidize copper? So we know that from the chapter of metals, copper is unreactive. What can copper react with? Not much. Copper can most react with silver nitrate. Copper, silver nitrate, copper nitrate, and silver. All right, to balance, you put a 2 there, put a 2 there. All right, and let's look at what happens. We know that copper is oxidized. Copper goes from 0 to +2. So which ion oxidizes copper? Silver. Silver ions literally gain electrons from copper. They form silver metal. Copper metal forms copper ions. We good? Yeah. Yeah.